Algebra 1, Lesson 8, Laws of Radical Expressions. Just like with exponents, we have formulas or laws that help us navigate through operating with radical expressions. It is important to know how exponents and radicals are related to each other. Radical expressions could also be written as exponential expressions by using fractional or rational exponents. Take a look at the formulas below, and we'll do a quick example next. Convert the following radical expression to an exponential expression. We have the fifth root of x. Referring to our formula, we can rewrite this as x to the 1/5 power. Convert the following radical expression to an exponential expression. We have the cube root of x squared. Referring to our formula, we can rewrite it as x to the 2/3 power. In our previous lesson on radical expressions, we discussed how we can split apart certain radical expressions that are not perfect squares. For example, we could split the cube root of 54 up like this. We look at the 54 inside the radical, and recognize that we could split it up into 27 times 2. Doing that, we recognize that 27 is 3 cubed, so the cube root of 27 would be 3. So after the split up, we have the cube root of 27 times the cube root of 2. We simplify the cube root of 27 to be 3, and we just multiply by the remaining cube root of 2. So our final answer is 3 cube root of 2. Some numbers will be trickier to factor, but with enough practice you should be able to recognize these opportunities for simplification. In any case, you can use this formula to assist you. When we convert our radical expressions into fractional exponents, we could create new formulas that are based on the previous formulas we learned about when we reviewed the laws of exponents. For example, the square root of 24 could be rewritten as 24 to the 1/2 power. The 24 can then be split up into two factors, 6 and 4. And finally, the 1/2 exponent could be distributed to both the factors. This gives us the following formula. Like with exponents, a radical sign could be distributed to both the numerator and denominator of a rational expression. A rational expression is just a fancy way of saying a fraction. So the square root of a over b is equal to the square root of a over the square root of b. The same rule would apply if we were raising it to an integer power, as well as if we rewrote the square root to be the 1/2 power applied to both the numerator and the denominator. Another formula that shows this is below. Like with variables, you can add and subtract like radicals, meaning radicals with the same root and same radicand, the number inside the radical symbol. For example, we can add 5 root 3 and 7 root 3 because they have the same number inside the radical symbol, and they are both square roots. So, when we combine them by addition, we get 12 root 3. We would not be able to add or subtract radical expressions like 4 cube root 2 and 6 root 5, because their roots and radicands don't match up. Lastly, to make fractions that contain radical expressions in the denominator easier to work with, we could multiply both the numerator and denominator by that radical expression, so it's like we're multiplying by 1. This will put the radical expression in only the numerator without changing the value of the original expression. For example, we have the radical expression 7 over root 8, and we want to rewrite it by rationalizing the denominator. First, we use the root 8 in the denominator and multiply it with both the numerator and denominator of the original expression. Then we do the simple multiplication to get our final answer, which is 7 root 8 over 8. Remember, we are still using our laws of exponents when we multiply root 8 by itself. We rewrite root 8 as 8 to the 1/2 and square the whole term, which means to evaluate it, we have to multiply the inside and outside exponents together. This gives us 8 to the first power, which is equal to 8. So now we are equipped with some new formulas for operating with and simplifying radical expressions. It is important to know the correlation between radical expressions and their exponential forms, so that you can decide which formulas you are comfortable working with. If working with exponents is easier for you, you are now equipped with the tools you need to convert radical expressions into exponential ones and vice versa. See you in the next lesson.